I even... Okay. I'm gonna have to play with this a little bit here. I think that's good now. Oh, wait. I'm peaking a little bit now. There. That's probably better. Moving the microphone so it sounds better. How are we all today? I had a revelation while I was on a Skype meeting about something that I didn't even need to be there for. So, I'm happy. Although I'm also sad at the same time because my car's broke. Not my company one, my personal one. Ah, okay. Why didn't... There we go. Face cam. Yay. Okay. My plant's trying to take over again. There we go. That silly plant. Anyways, so I don't know where... I don't remember exactly where we left off last time on this guy. I have one fully assembled. Along with a hat that plugs into the Pi. Although you can barely see the Pi one. And then a cable that connects the two that's just Cat5 cable. Let's see. Yay, I got sound good. That's okay, Spoon. If you want to have me just in the background, that's fine. I do that to you too. There, the music is back, Mike. Because remember, when you guys trigger my strobe lights, it sends off a different music. So I had to restart Winamp. Which, it should just be quietly in the background. Anyways, so... And like I said, I don't remember where I left off last time we were working on this project. But I've got one fully complete. I've got the hat for the Pi. I've got the cable that connects the two. And I was trying to play around with the programming in Python to get this. If I get an email, you'll hear a train horn. Spoon. But... Python was not letting me do what I wanted to do. It just kept giving me errors. I think I even flat out deleted the Python script. Yeah, I deleted the Python script. So now I'm using bash scripting. Because it works. So, I'm just using these I2C set commands to do things. And it works. Unlike in Python. So now, I can still probably use Python, and I still probably will use Python eventually, to initiate these, but in the meantime, I'm writing little scripts that are bash scripts that do things. So let's see if I'm right. Go Control X. So we do sh red swirl 1. And if you look, ding, it does a little red swirly light. I also, as you saw, I also did, while I was in there, I did green swirl, blue swirl, and I think purple was the other one that I finished. Although purple and blue are kind of close to the same. So, oh, I also did test swirl, which goes through red, green, and blue. So I can make my lights do things. I need to write more for blink. The different colors. I need to... let's see what else. Oh, I need to do a standby one to turn on the standby lights in the middle. So that's basically what I'm going to be doing, is sitting here talking with you, coding, and listening to a little bit of music. Oh. Before I get too far into this stream, hang on a second. I gotta check on something with a coworker that I'm supposed to be working with on Monday. Okay, sorry about that. Just had to send a message to my coworker. We are all good now. Let's see, make sure that the microphone is doing what it's supposed to do. Alright, so... Forgot to change focus on the screens. So what I'm gonna do is, let's see, I still need yellow, a light bluish, and a white swirl. So what we can do is we will write this out as a yellow. Swirl 1. Yes, so I'm going to save it under a different name. Okay, now we need to change these values. This is going to be a 5. Let's see, 48 in hex. What's 48 in hex? 48 in hex is 30. 128 is 80. And then we're going to switch, but at the same time I need that to be set to 1, and then I need that to be set to 0, and this guy to be set to, well, that's 12 in X, or 12 in decimal, so that is C in hex, so 0C. If you're wondering what I'm looking at, I've got a sticky note on my desktop that has all these values in it. Okay. Okay. Alright. Mike is posting donuts on stream. Alrighty then. Okay, we just did 12. So we need to do... Okay, so I need 5. Ah, I was looking at the wrong one. I've mixed. Okay, so... Okay, I gotta start over here. So, 40... 40 is actually 28. 28. 64. What is 64? Is 40. And that's still 1. And then that's going to turn off. This is going to be 10, which is A. And that, yeah, let me just make sure. Let's see. Okay, so 10 is going to be A. Then I got to do 880. Which is actually going to be in hex, that is 50. Repeat that down here. So 5, 28, okay, 0, 5, 28, 40, and 1. Okay. It's going to be 0 and A. No, that's 0, 1. Anyway, so how's everybody else's day doing? My week has been shitty, to tell you the truth. You know, between breaking my phone and everything else. Now the alternator's gone out in my car, so Okay, that didn't work right. Yeah, that didn't work right. I did something wrong. I forgot to do that. I don't know why it even ran, but I don't think that is actually going to cause this. In theory, I could, Mike, but you know, I'd have to pull it apart, check the windings, make sure those were still good. I'd have to pull apart the electronics for the voltage regulation, make sure all that's good, and if it wasn't, replace the parts. But, you know, they don't really sell just those voltage regulation parts anymore, so yeah. So here I've got to figure out how to come up with $160 and to fix it, and I don't get paid until next Friday. All right, so let's see what we've got going wrong here. So you want to go, yellow is going to be blue and green, so and blue works. So we've got again, I can't afford that either right now, Mr. Wells. Okay, so for blue, we've got 0, 2, 1, 0, 8, 0, 4, and 20. So this is for blue. Okay. All right. Now what do we got for well, no, wait. Red is going to be or yellow is going to be red and green, I think? Well, let's, yeah, because red and blue are going to make the purple, which I fixed. Okay, so this is going to be 04, 20. 8, 40, 2, 1, 0. Okay. So now I need to do math in hex. Or in... Yeah, math in hex. What one am I working on? I need... this one. So... I'm mixing red and green. So... 5 is correct because 4 plus 1 is 5. 20 plus 8 is 28. $40 for the red plus the 1 for the green. That is correct. And the next one is 10, so that is correct. And then 40 and 10, that's 50. Okay, so that is all correct. So what happened down here? Like I said, you'd hear a train sound when I got an email from work. Oh, they're sending me to even more. Training. Yay. Okay, hopefully that doesn't interfere with my other training that I'm going to. Anyways, back to this. You know what? What I'm going to do. Since I don't know what happened there. We're going to delete all that. Now I know with nano I have to do it this, I have to copy it that way. And then paste it that way. That didn't copy. I don't know what it just did there, but it just like screwed everything up for me. Okay, so that's one line off. Okay. That time it looks like it cleanly pasted it. Okay. Change this to address 21. Write it out. Exit. Change yellow. It's kind of more green than it is yellow, but hey, at least it's not doing funky colors this time. If you're wondering what's going on, is I've got... So this chip is labeled, or is addressed as 20. This chip is addressed as 21. This chip controls the 5 LEDs on this side. This chip controls the 5 LEDs on this side. And actually, I've thought about it. If I do this, this might get interesting. Oh, error, right failure. Oops. Okay, so now I have a kind of a yellow swirl. It's as close to yellow as we're gonna get. Let's go clear. Evidently, I am going to be learning our new vector hardware. Yay. Basically, it uses the Bluetooth in your cell phone to talk to the card reader to open the door for you as you step up to the door. Okay, just going to open up this one, but then I'm going to write it out as... What's the next one I got? Light blue. Yes, I want to save it. Delete the upper half again, or delete the lower half, I should say. Alright, so in light blue, what do we got? We got a... We got a 6. 48, which is... $30, 128, which is 80, and a 1. Then we do 0, 0, and 12, which 12 is a C. And then we do 96. Is 60, and then a 0. Okay. Oh, oops, I wasn't watching. Okay, that does 5 of them, so I got that. That halfway works. So I just need to come down here, go like, highlight it, edit, copy. Copy. Paste. Hang on a sec, guys. Okay, I know where I'm working Monday, and I gotta be up early. I gotta be on site at like 5 a.m. You never understood The Linux command line, huh? It's not that much difference than the Windows command line, Mr. Wells. The only difference is the syntax on the commands. And if you're wondering about that whole sudo thing is... So, you know how in Windows that there are some things out there that you have to run as an administrator? Well, Linux took that a step further, and not only do you have to do that in your Windows manager, but you have to do it in your command line as well. And that's what sudo means, is you're running this at a higher permissions level than what your user really is. Yay! Okay, I've got a blue swirl. Okay. We will write this one out as a white swirl, because that is my last one, I believe. I believe white is my last one that I have to do. Yep. And then I get to do blinks. Okay, white swirl. Okay, so for a white swirl, we'll do what we did on all the other ones, because it seems like if I don't do this, it doesn't work right for the second half of the swirl. I don't know why. Okay, so for white swirl, we need a 7, what's a 56 in text? A 38, a 192, where's my backspace? C0, and a 1. Okay, and then I need to turn that one off, and I need a 14, which is a 0E if I remember correctly. Not an R, a 0E. And then I need 112. Which is 70. And then back to 0. Okay. I'm almost scared to click on that, Mike. Remotely TPing somebody's house. Nice. Problem is, everybody'd know that I did it on my block, because I think I'm the only one that... Yeah, I think I'd be the only one that would buy a... See, that's more of a white blue, or light blue. Okay, so my white isn't showing up as very white. Okay. So convert this to hex. So I need 2 plus 4 plus 1 equals 7. Okay. Okay then. Well, my white and my light blue are about the same color, unfortunately. It is what it is, I guess. Oh, I need idle states. What are my idle states? So I need to do a sudo nano idle 1.sh to my little declaration, which I did that. Did it? No, I. Slash bin slash bash. I2c set dash y space 1 0 x to 0 here x 5 here x. What's 128 in hex? Zero, and then I also want to do this to 21. Okay, so now you get to see what it does when it's idling. There we go, now they're starting to deviate. Hi, Lady G. And those are some LEDs that I found that they automatically do that little color changing thing. Nano. What was that called again? SH So what I want to do is we're gonna go purple, blue, green, okay. So that's kind of cool. That just runs through all the swirls, and then my daughter just walked in, waved, and walked out. You know what I need? I need a... clear one. Yes, I want to save it as a new name. Zero. I want a clear function. Because this is ultimately it's going to be a lighting display. So I need the basic components for creating everything. Almost forgot to put the modifier in there. I wonder. Yay, okay, that works. So I have a clear command now. So what I can do is I can go sudo, or no, yeah, sudo nano test swirl. I can add in the sh clear dot sh, write it, x, yes, exit, sh test, I did that wrong. I forgot the 1. If you're wondering why I'm putting the 1 at the end of all of these, I thought I had to when I did running nano. Jinx, I've always done sudo nano. Am I doing that wrong? I've been typing out an extra 5 characters all this time, and I didn't even realize it. That's why I'm doing it that way, Jinx. Hey, it works. Okay, yeah, that's not getting too bad. So yeah, Jinx, when I learned Linux, I always did sudo nano to modify things. I never really thought about it that nano was probably not an application that required the elevated privileges. I mean, I know when I'm modifying like a system file, I need to do that. Still. Because system files are protected, but yeah. Mmm, crunchy. Peanut buttery. I think I excited Mike. Don't know how I excited him, but I excited Mike. Alright, now we're moving on to the blink functions. You know what? I am pretty sure I have a version of this that doesn't have the... Does this one have the blinks? Yes, this one has the blinks. Okay. You know, I thought it did too. Well, let's see here. I'm assuming CH own. Well. We'll do a test here, Jinx. CH own. Hi. Nope, it still activates. So evidently I2C set is not a yeah, okay. All right, they're all they're all no longer owned by Root, and we'll stop using that. Yeah, I guess I can use that since I made them executable. Okay. I need to go nano. Red blink 1.sh. And if you're wondering why I'm writing them in bash scripting, Jinx, is because I tried doing all this in Python with this beautiful Python code that uses the bus.write data command from a built-in library in the Pi that's looking for the address of the device, the address of the memory, and the address and the value to write to that memory. Well, okay, I put it in hexadecimal, and then it yells at me that it can't understand hexadecimal, so I converted everything to binary or to decimal, and then the chips don't respond to them because it's looking for something in hex. So I don't get why it's not working. So I'm just like, screw it. I know bash works. So what I can do is, once I get all these little bash scripts written for each little function, so to speak, then I can just use a Python script to call on the bash scripting and not have to worry about this whole decimal hexadecimal bullcrap that Python is pissing me off with. So I did use the 0x notation on him, and then it yelled at me that it was, oh, you're trying to put a string into something that's looking for a number. Yeah, I know. And I'm seriously thinking about writing it all in bash. But, right now I'm building the basic building blocks. Kind of like, think of these as functions, I guess you could say. No, I didn't put it in the quotes. Is that my problem? Actually, I don't need to copy that. Why am I doing that? Okay. See, and I keep doing stuff like that. I accidentally type in the 1 key instead of the I key. Let's try that at half a second instead of 1 second. 1 second's a little long. Yeah, and see, I was doing that and it still wasn't working. So I gave up on the Python actually doing the raw sending data out to the unit. And I'll use Python. I'll use something, either Python or C or something, to call on these bash scripts. And these bash scripts will be the one that'll actually do the writing. Ultimately, all this stuff is getting controlled remotely from one of those Asus Maker Studio touchscreen tablet thingies that's pretty much a Pi with a tablet on it, or touchscreen already attached to it. So what I might look into doing is running bash scripts remotely. And doing all the logic in the touchscreen controller at the other end of the other end of an Ethernet cable. Okay, for blue, this needs to be 92. This needs to be 24. So 92. 24, 0, 0. Write it out. Set chmod plus x blue. Yay, blue works. Okay, now I need purple blink. See, the nice thing about this is like I said, all I have to do is, save it, basically do a save as, a different name, and then change these values. So that's going to be a D8. That's going to be a 3, 6. D8. That's going to be a 3, 6. Write it out. Exit. Yeah, yeah, I'm gonna do that. Didn't I just do a purple? It's because I haven't chmodded it yet. Okay, 2 of them are out. I gotta figure that out. Let me just... Okay, so those LEDs do work. But which ones are those? Those are 1 and... Okay, so they're the first ones on that. Okay. So they're LED 1. I don't know if this one's correct anymore. Okay, so that does come on. So those do come on. Okay, okay. So why didn't that value work? Okay. So I need to go back into nano. Okay, I need to find out why D8 didn't work. Yeah. See, I still don't know how to do the functions inside of Bash. Alright, so to do purple, LED 1 is 3. Oh, here. Let me actually do it here. So, do I have a calculator on this thing? Calculator. So, change it to hex. So, we've got 3 turns on LED 1. 18 turns on LED 2. And C0 turns on LED 3. dB. That's why I have it. Okay. That's why it didn't work, because it needs to be dB, not D8. Yay, purple blink works. Clear that screen. It's getting messy. Yeah, I'll have to Google it later. Because right now I'm... yeah. Okay. We'll just do this one. We'll write this out as green blink. Green blink, yes. Green blink is going to be 24 and 49. Yeah, I'm probably going to be doing expressions and parameters like that when I get to doing the more complex thing, because I know I'm going to have 8 of the 8 of these modules. I'll look it up in a minute, Jinx, okay? And then we'll try it. Alright. You know, I don't know if I've ever connected this thing, had this thing connect to the internet. Evidently I had. Let's see. Functions in bash script. Function is a great way to reuse code in a section of your bash scripting tutorial. Let's see. Okay. Okay. Let's see if this works. Okay, so... which one am I in? I'm in light blue. Have I done actually... light blue has not actually been done yet. Okay, so what we will do... is we will... go like... okay, so we will go... do I... oh, that was the other thing that was ticking me off about Python. Was, tab versus space. Because it cares in Python. Night, Mike. Okay, add one red one set. Add two, add one red two set. But I don't think I need... yeah, I need that in here. Actually, you know what? I can actually do this. I can do this smartly. Okay, so I think... I just want to make sure I'm doing this right. Do I separate it with a comma or something? Okay, yeah, so it looks like... So, I should be able to do... Red 1 set... Wait, how did they do that here? Okay. So, what you've got is... So, I2C set is the command. -Y means that you're writing to the bus, to a specific bus number. In this case, bus number 1 for the I2C bus 1. The first decimal hexadecimal value is the address of the device on the I2C bus. In this case, 20 and 21. Then the next hexadecimal value is the register, the memory register inside that device that you're either reading or writing to, because there's an I2C read, I think, or no, it's I2C get is the other command that will actually read from these memory values. And then the final hexadecimal value is what's actually getting written to that memory address. In this case, it's because these are they're basically IO expanders. So they've got on them, what is it, 16 general purpose IOs that can be either input or output. And since bank A or register 14 in hex is already set to be outputs, when I write to that, basically take the hexadecimal value, convert it to binary, and that's what of the 8 bits will turn on. So if I write to it FF, all outputs will turn on. If I write to it 00, all outputs will be off. And the value that I'm putting in there, like for example, on this one's going to be light blue, I'm going to be putting B6, which it turns on the red and the blue LEDs of my multicolor LEDs to mix to make purple. And I sat and I figured out with how I came up with these values is I sat and I figured out, okay, if I turn on output 1 and 3, on this, on this bank, I will get this color for this LED. If you're following me here, Jinx. it didn't error out, and it kind of worked. But I got some green mixed in with that. So, again, I gotta check my values to make sure that my values of beat. That's why. I was looking at the wrong line on my thing. I was looking at the wrong line. That shouldn't be a 5B. That should be a 6D. And actually, that's going to help me out, Jinx, now that I think about it. Because if I can pass arguments to a bash script, because I can return a value. Okay. Let's see, variables. Okay. Alright, so let's come back here. Let's see. So I literally just okay, so yeah, I just need to do okay. Okay, yeah. For example, on purple. Purple was David Bravo and 3-6 on Bank B. So Bank A was David Bravo and Bank B was 36. Whoops. That was actually supposed to be address 2. See, this is what I was running into in Python. But I may have a way around this. Hang on a sec, guys. Okay, that was work, and see, this is the stuff I was running into in Python, and it was pissing me off. So... Okay, give me a second, let me get to that. Let's see here. Okay, let's see if I can transfer that to the Pi. We will go ahead and... This didn't work. Let me just finish the put this back the way it was when it was working, and then we'll test yours, Jinx. Write that. We will... Okay. We will exit. We will... Nano... Blinky. .sh. Let's see if this works. Of course it didn't work. Why would it be simple? Oh, okay. We'll try that in a minute. I'll go back and try that, but let me get yours here. Okay, so it's not letting me... Is there just like a notepad somewhere here? Text editor, that'll work. File. Minimize this. Do an exit. No, don't save anything. Come back here. We will go File, Save As. On my desktop, in here. We'll do blinky.sh. Close it. Unless it. We'll do sudo chmod sx asterisk.sh. Just make them all executable. That works, Jinx. Well, you saw how I ended up having to do the copy and paste. I had to copy it and then paste it to a text editor in the operating system and then save it as the script. So yours works. Okay, that was helpful. So I know. Okay, so I know I can do those things. But we're gonna go back to light blue blinky here, and we are gonna do address 1 equals $1, address 2 equals $2, and then you were saying I need to go $address 1 here, and $address 2 here, $address 1, or no, this is going to be 1, this is going to be 2, and then address 2. Programming in Bash script, yay! Well, now that I know there's like if statements and stuff, I might write this whole thing in Bash just to confuse people. What's this written in? Bash. Yes, it works. Because PowerPoint doesn't work on a Pi. I mean, I have... What is it? I think it's this one, Impress. But Impress doesn't function like PowerPoint. I don't have all those nifty animations, Spoon. And he warns you in the video that third-party programs don't work right. Okay. Since I haven't figured out how to... I can't remember how to do this from... light blue blink. Rename... There we go. Okay, so now I can remove all the... I can now... That's gonna be fun. I can now redo all of these scripts. To be like that, yeah, yeah, see, and that's the thing, Jinx, that I2C set binary is actually built into the kernel of Raspbian. The other one that's built into there is I2C detect. Whoops. I forgot to tell it which bus. Which will tell you everything a single I2C device on the bus. 0, 1, and 2 are dedicated to internal stuff that's on the Pi that you can't play with. I mean, I'm sure if you hack into it, you could play with them, but... I can have up to 77 devices on a single I2C. Well, theoretically, I could have that many. But there's a problem of capacitance at that point. I'm trying to remember what the other I2C bus command is. I believe it's I2C read. Nice. Okay. Okay, yeah, it's I2C get is the other one. So yeah, and then the other one is I2C get. Sorry, I'm trying to remember buffers here. Okay, so yeah. If I do 1.4, well, if I do ./idle, now if I do that, now you see it's 80. Okay. Will I have issues in Go with that same thing of this is not a number BS? I mean, I solved it here, but let's see. Well, to give you an idea, let me... Okay. Well, let me rewrite the Python script really quick and I'll show you here. Programming, where's my Python one? Python 2. Actually, I just need time. Do I have to... I think I broke things, Jinx. It's not liking me. It won't let me delete those. Okay. Close that out. Okay, so what I need to do is I need to go to my own GitHub. I want to sign into GitHub. I don't want to... I'm already a user. Where... Okay. I think this is it. Yeah, this is it. Where's my download? Okay. Give me a second. There. folder. Just dump it there. Go away. Yes, delete it. Go away. Empty. Yeah. Okay. Text editor. So I don't need half of this stuff for this test that I'm about to do here. Okay. See, it errors out if I try to write to something that isn't on the bus, so... I don't need the listening server because I'm not going to do that this time around. Plus one. Okay. I forgot how to execute a Python command. Let's see, what did Lady Jinx? Your cats are silly. Okay, Python. Okay, so if I just go Python. Well, hey, that worked. It put it into an idle state. So let's try. Some more here. So if I just do. What if I just do. See, I don't like that about this IDE. That was really quick, but it worked. Okay, it's because my blink time set probably really low. Blink. Oh, yeah. Wait, 5? File save. Okay, that's doing a little bit different. I wonder if I can't really execute them simultaneously, can I? Bet, though, if I did this. Error, crash. Yeah. Hmm. Yeah, I flipped the wrong switch back on. Now if I save this and I close this, and if I open it in the other... Yeah, so it works in Python. Let's see. I loaded this one back up because it does autocomplete for me. So if I go per and purple blink, device 0. Okay, it doesn't always work perfect on the tab complete, but we'll try a swirl to see if my swirl works. And then we'll do idle state. It's rather flashy. Okay, that swirl is too slow. And that blink is way too fast, so... Okay, so it works. Let's speed that swirl up just a little bit. So I don't know why that was having issues the last time. Something's going right for me this week. Yay. I can do is I can come over here. I can come to this. Let me see if I can make this a little bit bigger without putting it off the screen. I don't need to see the shell as much. So if I go, and if I comment out that, comment out that, and comment out that, and comment out that, and comment out that one. Basically, I'm taking out every reference to device 0 or device 1. So light blue, blue, purple, red, yellow, green, blink, device 0. Oh, I forgot a 0 on there. Let's see. So I got blue, purple, red, yellow, green, light blue, and white, blink, device 0. Okay, so we're gonna do some more swirls. So we're gonna do light blue swirl. We're gonna do blue swirl. We're gonna do purple. Basically, I'm just testing all of my functions that I created in this thing already. And once this is working, you know, this is kind of funny. I created I created this. It pissed me off. I abandoned it. Then I'm like, you know what? I'm just gonna write it in Bash, And now here I am, I'm back in Python, doing it back in Python because it actually works in Python. Okay, let's see, can I do... Okay, finding all those. I want to see which ones were messed up because I saw that some of them were messed up there. Okay, light blue works. Blue kind of works. Purple doesn't work right. Red works. Yellow is the one that doesn't work right. Green kind of works. White kind of works. Okay, light blue spiral. Okay. Yeah, the colors are off. So yeah, my coloring scheme is off. I don't know why. And one of them's broken. Oh, I know it's the one that's broken on the blinking. That'll fix that, but it's not actually yellow. Okay, that fixed that. Alright, so first... Alright, so I need to increase my blink time so I can actually watch this here.
I'm afraid driving the car to see his dad's come back.
Huh?
I'm afraid driving the car to see his dad's class and back.
Okay. Okay, so light blue, green, yellow, red. Okay, what was that? Light blue, green, yellow, red. Purple, blue, white. So, light blue, green, yellow. Okay, so up here, so that's the order that these go in. so the actual order I get is light blue, green, yellow, red. So light blue. Blank. Green. Blank. Yellow. Red. Purple, blue, white. Oh, now I remember what happened with this on the coloring. Is because the pinout on these LEDs are different than the ones that I was using on that breadboard wherever it went. So that's where my discrepancy in that is coming in. Now let's check the swirls. Light blue, green, yellow, red, purple. Okay, so light blue, green, yellow, red, purple. Okay, so a wild KB is following me. Thank you, KB. I'm programming in Python today. If you're even there. I don't even know if he's there. You are there. Okay. Yeah, so I've been playing around in Python, making things swirl and light up and things like that. Okay, so I need... You really want to refactor this Python script. Don't you, Jinx? Okay, so red swirl is red swirl. Okay, so that's correct. Green swirl is actually blue swirl. Which is going to yell at me because now there's going to be two blue swirls. So red swirl, blue swirl. Blue swirl needs to be green swirl. Yellow swirl needs to become purple swirl. Whoops.
Sorry.
And yellow. Swirl. Purple becomes yellow. Light blue stays light blue. And white stays white. Okay. Yeah, I know. I'm sure there's a joke in there about that somewhere. Okay, with blink. Red blink is actually red blink, so it can stay. Green blink needs to become blue blink. Yellow blink needs to become purple blink. Blue blink needs to become green. Whoops. That wasn't the backspace key, that was the enter key. Green blink. Purple blink needs to become yellow. Yeller blink. Yellow blink. Light blue stays light blue, and white stays white. Okay. Save it. Run it. Light blue, blue, purple, red, yellow, green, white. Yay, I fixed all the colors. Yeah, that is kind of cool that they're going to do that. I doubt I'll be doing it because I need to do I need to get to work on this stuff. How warm is that getting? It's not getting too warm. Yeah, I'm gonna close this for a minute so Jink stops twitching. Yeah, my biggest thing that I gotta do now is I gotta figure out the alternator on my wife's car because it's dead. And it's gonna cost me $160 to replace it, and I don't have $160 right now. So, yeah. Don't know what I'm gonna do. But she insists on still driving the car, and that's what our conversation was a few minutes ago. Was me basically telling her, well, I have no way to come rescue you, so good luck. Eh. I don't know. We'll see. I'll have to go rescue her later, so. Okay. This should be late. Because, yeah, it'll go through all the animations that I needed to go through to test to make sure that that all's working. Okay. CD light scripts. Let's go. Oh, I don't have a way to set them to solid colors. I only have them swirling and blinking. God, I have to make it executable first. Oh, I forgot to define the addresses. That's right. What I'm trying to do now is I'm trying to see if this thing gets hot. Because if this gets too hot, running all those LEDs, I might not be able to do solid colors. That's right, I changed my addressing scheme for that stuff. That actually gets pretty warm. I might not be able to do... Yeah, I might not be able to do solid colors with this thing. let's see, how long have I been streaming? About 3 hours. Well, I've learned a lot. Thanks a lot to Jinx. So, I'm calling this a success. I'm going to have to get that better voltage regulator, though, if I'm going to do solid colors. I just proved that because that thing got warm enough that I didn't want to touch it anymore. The chips themselves are staying cool. Even the I2C buffer chip. Let's see. Welcome. I can't read your name right now. Let's see. Quibla? What I'm doing is this little thing here, I'm actually going to be making 8 of them total, is a lighting thing that I've written, or that I've constructed. There's some of my past streams, you'll probably have to go to YouTube to get the videos now, but I did the circuit design and the assembly of these, and now I'm doing the programming for them, which I'm using a Raspberry Pi to control the lights, and like I said, I'm going to daisy chain 8 of these together, ultimately. And what I can do with them right now... Oh, whoops, I'm in the wrong directory. Python light test.py. So what I can do... Helps if I spell Python correctly. Is I can, make the lights blink in different colors. And then I can make them do a swirl pattern in the same colors. And then I've got these, I call them the idle LEDs, but they sit and they change color in the center. Yes, this is all coming out of one Pi. But you'll see... I'm not powering the LEDs off the Pi, I'm powering them externally. It's kind of hard to see here. So I've got a benchtop power supply that's running 12 volts that I'm feeding in to this. And then that 12 volts is getting used through a voltage regulator to step it down to 5 for all the chips on this circuit board to run. I need to get better voltage regulators because I'm overheating these ones. I've got them on order, I just haven't paid for them yet. So... the interface that I'm using for the Pis to the LEDs is... Let me see if I can find one here. I'm using I2C out to some microchip bus or multi-port I/O expanders. The 16-bit. Let's see if I can get this here. You know what? Let me see here. Let me change this here. Workbench. So it's bigger. It's upside down. I don't know if I can get this thing to go into focus or not. Where's my focus buttons? Yeah, I'm not gonna get that to go into focus. Yeah, not gonna get it to go into focus. But these are the microchip MCP 23017Ts, which are a 16-bit input-output I/O extender that runs off of I2C. And then I found from... Who was that? That's my linear voltage regulators. In just browsing on Mauser, I found these I2C extender buffers from, I believe they're Texas Instruments. Let me look here. I'm looking for them. There they are. Oh, and excuse me, they're from NXP. They're I2C bus extenders. They're the P82B715TDs. And what they allow you to have an I2C bus up to 1,000 feet. And then, like I said, I've got, so it comes out of the I2C bus on the Pi into the buffer chip, and then the buffer chip puts it up onto the Cat5 cable that I've got here. That's just running some standard automotive connectors that I also found on Mauser, and then it comes into here, and then that is paralleled with this one to go out to the next one, but it comes into the buffer chip here, and then that buffer chip drives the I2C of these two chips, kind of thing. Yeah, I didn't know it was going to work at first, so you'll see that I did a whole breadboard construction of it. To test it all out before I actually designed and built the circuit board. And then I go through allpcbs.com, and I ordered 10 of them, and they got me like 12 of them, but just the raw circuit boards in black. But the thing is my church is putting on a thing for Vacation Bible School, and we have a ton of these CD cases just sitting around. So the thought is, once the lighting is all complete, this is probably gonna get ended up glued into the top like that, and then I'm gonna drill some holes out the bottom, and then this plastic's gonna go over it as kind of a diffuser. I haven't figured out how I'm gonna get the diffusion done yet, though. Well, so far, this is the first time that I've been working with a Pi and high-level stuff. Most of my stuff that I've done has been mostly low-level. I mean, I did a little bit. I've got, let's see, this one here. Yeah, it's gonna daisy chain in and out of lights. Eventually, once I get them all built. But yeah, my other project that I've been working on is this, that guy. And yes, it is running on a Raspberry, that is running on an Arduino. It is not a Raspberry Pi. So if we can see here, whoop. See, there's Arduino bot. He is actually there. He will actually respond to your commands. But yeah, what I'm trying to do... see, my cameras like to shut themselves off every now and again. So what I'm trying to do is I'm just trying to get the coating down on these before I start building the other 7 of these, because I'm going to have a total of 8 of them up on stage at my church. And yeah, Spoon just shut off my strobe lights. But yeah, so I'm having fun with all this. Ultimately, it's not going to be my benchtop power supply powering all this either. The Pi and is going to be installed in this. It's a 6 amp power supply that operates at 12 or 24 volts. I'm going to be operating at 12 because most everything on my system runs at 5, and I've got 5 volt regulators. So, but yeah, this is going to be stashed just off stage and provide me with the 12 volts that I need to run the whole thing. And then I'm just going to mount I'm going to, probably with just like double-sided sticky tape, stick the pie in here so it's contained. What do you think? And my son just shrugs when I ask him that. At the moment, I'm using the linear. Let me get the exact part number on them. Which ones are these? The linear. The 1 amp 5 volt regulators. But what I have on order some 5 amp regulators. And then I just have, you know, a couple of capacitors on there. Let me see what the actual part number is of the ones that I bought. The ones that I bought... Oh, that's the I2C again. These are actually on semiconductors version of them, but they're the SCD 7805s. So, yeah, the 7805 voltage regulator. I figured, you know, I have a, you know, I thought 1 amp would be enough with that heat sink that they're attached to. But, I mean, just doing that idle animation is good. Doing the blinking and the flashing, it stays pretty good. But if I do the solid, whoops. Well, it's, like I said, I'm not 100% sure. I thought I did the calculations correct, but I've got, what is it, 10 total of these. And when they're running, like, I'm not even running them all, because these are RGB LEDs, so they're technically 3 LEDs in one. So technically I've got 30 LEDs on this board, all running about 30 milliamps. So, what is that? 30 times 20. So yeah, I'm running about 600 milliamps plus the chips. So I am pushing just over an amp. Yeah, so the LEDs are pulling just you know, around 600 milliamps, and then you've got this chip and this chip that pull some. This one probably doesn't pull very much, the buffer chip, except when it's sending or receiving data. So, but the reason I'm ordering the 5 amp ones is because they're not that much more expensive than the 2 amp ones, and I need a 5 amp one to power the Pi. And I'm reducing cost of material. You get them cheaper if you order them in bulk, so I'm ordering 10 of them. I mean, it's not getting super hot to where I can't touch the heatsink. I mean, I can sit here and hold my finger at it, but it is getting warm. And like I said, I'm not even running that full. If I go like this, and if I change this to white solid, and I change the values to, what are my values for white? What are my values for white? FF and 7F. FF 7F. FF 7F. CHmod, oh. Sudo chmod plus X. Yep, I forgot the address. There we go. So if I got those all on, I haven't seen it malfunction yet over time, but then I haven't sat and let it run for extended periods of time lit up like this, pulling max current. I mean, actually, I guess I should kick on the other LEDs to pull up max current, so. You know what I can do? I can do I2C set dash y space 1 x2 0 0 x14 0 x ff. That'll turn on half of them, and then we'll do. I don't know what I just did. I don't know what buffer I just wrote to. Actually, I do know what buffer I just wrote to. I just turned all those back to inputs. Up. 5 and F. See, and yeah, that's actually getting a little warm. Yeah, see, with all of them running, that's actually getting kind of warm. So,
The cord on TV coming out on the cards.
yeah, so I'm gonna get the bigger one, but yeah, Jinx. The issue with it is the regulator's only rated for 1 amp or 1,000 milliamps. So I'm overloading the regulator is essentially what I'm doing. So if I've got, oh, I need to switch it back to decimal. So if I've got, let's get this one back to a basic. Well, it's not so much the thing that pulls the most is the LEDs, and I essentially have 10 RGB LEDs with 3 diodes each, so that's 30 LEDs right there. Then I've got 4 more on top of that, so I have 34 total LEDs essentially on this board. And if they're all doing 20 milliamps, that's 680 milliamps right there, just in the LEDs alone. And then so then, you know, I have the spec sheet for those. Here, give me a second here. You're gonna see a messy desktop here. Okay. Ooh, Streamception. We'll minimize that.